All right. Hello, everyone. Thank you for joining us today for Infinitum's Right Sizing webinar. My name is Jill Denny, and I'll be your moderator. Today's session is led by Stephen Matthew and Cam Witt from our product marketing team. During today's agenda, Stephen will cover what is right sizing and what can it do for you, and Cam Witt will take us through an in-depth interactive session with Infinitum's motor selection tool. Lastly, we'll open up the floor for Q&A so we can have a conversation with our experts. We encourage you to ask questions anytime throughout this presentation using the Q&A interface. At the top right of your screen, you should see a Q&A chat bubble. Feel free to chime in anytime throughout this presentation. Luke will be assisting in our QA moderation and will address those questions at the end of the session. Infinitum's motor selection tool has a robust offering of features, benefits, and downloads. And if you haven't already registered for the motor selection tool, take a chance to do that now before Cam gets into our in-depth interactive session. At mst.goinfinitum.com, in the top right, you'll see a sign-in button. This is a quick 60-second login with your email and company name. It'll verify through your email, and then you'll be taken directly into the tool. This is a great feature that'll allow you for benefits in the future updates. You'll get notified first, so don't forget to go ahead and register for the motor selection tool. All right, I'd like to introduce our technical experts today from the Infinitum product marketing team. Stephen Matthew, our Director of Product Marketing and expert in all things motors, and Cam Witt, our Product Marketing Manager, who is the knowledge champion on everything behind the motor selection tool. Before I pass it off, just one quick reminder where the Q button is, and feel free to ask questions anytime during this presentation. Stephen, I'd like to pass it over to you.
Thanks, Jill. Good morning, everyone, to this right sizing webinar. So what is right sizing? This is a question a lot of our customers have been asking us, and some of you are confused between a right size motor and a standard motor. We hope to untangle all of these questions in today's webinar. In a nutshell, right sizing allows motors to be labeled based on the specific load point of an application, thanks to our flat efficiency curve. So let me explain what that means. All motors have an efficiency curve. Typically, motors are most efficient when running at the rated horsepower and speed. But as you reduce the load and speed, the efficiency tends to drop. However, for infinitum motors, the efficiency stays flat, even when the load and the speed decreases, giving IE5 grade efficiency on a wider range. This is what we mean by our flat efficiency curve. Now, it's rare for an application to run at its typical full load speed at all the time. Say 10 horsepower, 1800 RPM, or 5 horsepower, 3600 RPM. Depending on the duty point, this could be 9 horsepower or 3.4 horsepower. In the case of AC induction motors, customers did not have a choice and were forced to use a standard 10 horsepower or 5 horsepower off the shelf. With Infinitum's AirCore EC, we can custom or right size that motor nameplate for that application. So in this example, the nameplate labeled 2 is the motor running at the optimal speed, 10 horsepower, 1800 RPM. Motor labeled 1 is the right-sized motor with software changes running that motor at, say, 5.9 horsepower, 1225 RPM. Now let's discuss the benefits of right sizing in the next slides. So how does a right-sized nameplate benefit you as an OEM or an end user? First, reduced upstream electrical infrastructure. So the reduced upstream electrical infrastructure translates to cost savings and decreased Scope 3 emissions. So in this example, the motor on the right is the standard 10 horsepower 1800. And in this particular example, the customer has decided to use a right size motor, which is a 5.9 horsepower. And so that reduction in current, almost 4.9 amps, reduces upstream electrical infrastructure. You see, when a facility manager designs and builds out a facility, they rely on the motor's nameplate to determine the required upstream electrical infrastructure. So in this case, the 4.9 amps of reduced current draw means smaller equipment. Think smaller wires, smaller transformers, smaller circuit breakers. So this not only simplifies the setup, but also saves you money on these smaller components. But there's another important benefit to right sizing, and that is your Scope 3 emissions. Scope 3 emissions are the indirect greenhouse gas emissions that occur throughout the value chain and your supply chain. In this case, they are tied to the production and transportation of all the upstream materials, like we discussed, wires, circuit breakers, transformers. By requiring smaller components, less resource-intensive components, we are helping to reduce those emissions as well. So it's not just about cost savings. Right-size motors is also about sustainability goals. Another benefit of right-size motors is the increased capacity for other equipment, which results in the improved power usage effectiveness, or PUE. I mentioned that right-sizing your motor helps increase the capacity of other equipment. You're all familiar with PUE, or power usage effectiveness is a ratio of total power used by a data center to the power delivered to the IT computing equipment. It's a very popular KPI used in the data center world. Let me explain how right sizing improves PUE. Imagine two different facilities. On the left here, we have a facility designed with standard nameplates. This nameplate dictates how much power is allocated to the cooling equipment. For instance, in this example, we have 400 motors, each motor delivering 7.5 kilowatt, and that totals up to 3 megawatt allocated cooling. Now let's look at a facility designed with right-sized nameplates. That's the label in red. This customer knew the exact power required for their application, in this case, 4.4 kilowatt. And so for 400 motors, that reduces the power to 1.76 megawatt. What that means is the difference of 1.24 megawatt is now freed up for additional IT computing equipment. This impacts your power usage effectiveness. Both facilities receive 10 megawatt of power, but the one on the right, using right-size motors, can dedicate more power to the IT equipment, improving the PUE and overall efficiency. So there you go. Right-sizing is just not about optimizing the motors, it's about creating more capacity and more value for your entire facility. And by the way, Cam will show you how to pick the right size motors and the standard motors in his presentation in a few minutes. Now that we have covered the benefits of right sizing, let's talk about the tool that makes it all possible, the Infinitum's motor selection tool. Our motor selection tool does more than just help with sizing. It generates detailed data sheets, drawings, customized parts, and it can even calculate the energy savings, along with a variety of other capabilities that Cam will also show you. OEM vendors can also use this tool to offer products that are truly right-sized for their customers, ensuring better performance and efficiency. This is one example of how one of our OEMs, Basics, has incorporated Infinitum's motor selection tool into their fan selection tool. In this case, basic software automatically queries the motor selection tool behind the scenes using APIs and provides a right-sized motor with the fan based on the duty point. The beauty of this solution is that it allows BASIX users to pull a right-sized motor and the data sheets and design parameters directly from the fan selection tool. Some of our other OEM partners have also integrated the functionality into their fan selection systems, allowing them to provide right-sized motors from the start. So far, we've been discussing the benefits of right-sizing. Next, Cam will discuss the how of right-sizing, particularly how to use Infinitum's motor selection tool, how to create right-sized motors, and how to generate all the design parameters and the data sheets out of the tool. But before that, some housekeeping. I wanted to remind everyone, submit your questions using the Q&A button, and we will answer these questions along the way. So over to you, Cam.
Thank you, Stephen. As Jill mentioned, I'll be running this on a live demo, and this is actually based on the motor selection tool found on the company website. So I'll start the motor selection tool up by going to Resources. And at the far left is a tab for motor selection tool, and select that. So this is the entry point, the main data entry point for the motor selection tool. And the motor I was going to use was the 5.9 1225 motor that Stephen used. We're going to use that for our example. So I enter in the desired power, 5.9 horsepower. You could also use kilowatt if you're more comfortable using kilowatt nomenclature. There's a way to do kilowatt entries as well, but 5.9, 1225. But the orderable options are available in this blue bar at the top. So for example, we have 460. We also have 415 volt motors. The default is Modbus communication, but you might use BACnet in your facility, so you could click on BACnet. We have steel bearings, or if you're more comfortable with hybrid ceramic, you can choose hybrid ceramic bearings. We have different grounding options. The default is a grounded Y, but we also have delted or high resistance grounds, depending on the infrastructure of your particular application. So I'll leave it as it is. It's 5.9, 1225, Modbus steel and grounded Y. If you want to adjust your ambient operating conditions, our normal recommended maximum temperature is 40 C, but we can derate. We can go up to 50 C by derating the motor. We can go from 1,000 meters to 3,000 meters. You just input those numbers here to adjust your ambient operating conditions for your operating point. So I'll go back to config options. We have the selection chosen, and I'll hit the submit button. Second. Put the number in here. 1225 and submit. So when you hit the submit button, you'll see it brings up two cards. The left card is the information for your right size motor. The right card is the standard motor. So the tool was first designed to give our factory personnel information on how to build the motor that a customer selected. So in this particular example, the customer wanted 5.9 1225, and it's based on the 10 horsepower 1800 motor, which is shown on the right. So looking at the left information, the frame size is a 20-inch frame. The information on the rated power is 5.9, that's 4.4 kilowatts. The rated speed is 1225. The system efficiency is 91.3, and you can see the standard motor is 91.8, so it's slightly less because you're running it at a slightly reduced speed. And let me comment a little bit on this asterisk. You'll see for the efficiency and the amps, there's an asterisk here. So these numbers are calculated. And let me give you a little information on the math behind the motor selection tool. The tool has access to the dynamometer data of all the standard motors. So we take that operational data, put it into an equation, which gives us a way to add this particular value and determine these experimental numbers for efficiency and amps. So you plug in 5.91225 in the linear regression, and it provides 91.3 efficiency based on the data from a 1018 motor. You can see this motor is 7.1 amps. And this is where you get the savings that Stephen was talking about. So the 1018 is a 12 amp motor, but this 5.91225 is a 7.1 amp, a savings of almost 5 amps. You see the torque is here, 25 pound-feet, 34.3 newton meters. Supply voltage is 460, steel bearings, and it tells you the shaft length. So I'm about to click this more info button at the bottom. And as Jill mentioned, to actually get the advanced features of the tool, you have to register. So if you haven't registered and you click the more info button, it's going to require you to register. In my particular example, I've already done that. I'm cookie. So it takes me directly to the advanced features of the motor selection tool. You can see on the left side is the information we talked about before, but now we have new things on the right. There's an energy and CO2 tab, an operating point tab, an efficiency curve tab, and a more info tab. I'm going to go back and click on the energy and CO2. And this is a way for the motor selection tool to provide you energy savings based on your motor compared to some IE2 and IE1 and IE3 motors. But there's programmable information here. The energy cost you can change depending on your regionality. Here in Texas, it's 17.5 cents per kilowatt. We're going to set it for 24 hours a day. You can adjust the hours a day you want to run your example and how many days a week. I'm going to leave it set at 7. On the comparison, you have 3 motor types to choose between: IE1, IE2, and IE3, all including a drive, because you want to compare it to the Infinitum motors that include the VFD. In this particular example, we're going to leave it at 10-year motor lifetime, and the standard CO2 per kilowatt calculations in the lower right-hand corner. So if I click the submit button, this compares our particular motor to an IE2 plus drive. You'll see when you compare this right size motor, it's almost $9,592 in money savings, 22.8 metric tons compared to an IE2 motor. If you go back and change this to an older IE1 motor and hit submit, the savings are greater. So it's $13,600 with a savings of 32.4 metric tons. If I compare it to a more advanced IE3 motor and hit submit, the savings are still substantial, 7,305 and a savings of 17.4 metric tons, comparing your right size motor to an IE3 motor plus a drive. I'm going to go back up now and go to an operating point tab. This is a way to compare your motor to other applications you might want to base your motor on. For example, it's 5.91225. If you want to run the motor at a reduced horsepower, say it's 5 horsepower, you put 5 on the output power, hit the test button, and you can see at this operating point, your 5.91225 that used to be 7.1 amps, if you run it at 5 horsepower, it's only 6.3. So as expected, there's a reduction in amperage depending on the output power. If you change it to 4 and run test, at 4 horsepower, 1225, it's still 91% efficient, but it only uses 5.4 amps. As expected, when you drop the power down, the current goes down proportionally. So you can actually save this to a file by hitting the export CSV. All these test points that you created here, you can actually dump it to an Excel file if you want to do some further analysis. Now I'm going to go back up and click the efficiency curve tab. Here's the same chart that Stephen referred to in his presentation, but I wanted to mention that the top line, the gray line, is a torque curve. And for all Infinitum motors, between 60% and 100%, we guarantee 100% torque. You can see by this flatness of the straight line at 100%, this motor gives full torque between 60 and 100%. This next line, this brown curve, is the efficiency curve. As Stephen mentioned, it's very flat. Even at low rated speed, it's a very high number. And horsepower, as expected, is this diagonal line from 60 to 100. This shows you how that horsepower changes with rated speed. When I click the More Info tab, there's some things you can see on the screen. It gives you the outside dimensions of the motor. But more importantly, it gives you a way to download drawings or step files if you want explicit drawings and step file information for your motor. And again, it's tied to this unique motor. And I'll tell you some details in a second. It also gives you a data sheet. I'm going to go ahead and click on that. And what the tool is doing is creating a data sheet based on the input parameters of the motor that you've chosen. So I click on the download, and you can see it's a PDF file that's been created. It's 5.91225, which is the unique horsepower and RPMs that you selected in the beginning of the tool. There's marketing information here. There's a representation of the internals. You can see the various components in a blow-up diagram at the bottom. Here's a performance curve that you can actually use. We discussed this previously. But you can see the motor information. This is explicit information that was designed based on the motor that you selected. So it's 5.9, 4.4 kilowatts. You can see the torque, the rated speed is there. It also shows you the maximum speed. The maximum speed with this particular motor is 2160, and the minimum speed for every Infinitum motor is 100 RPM, and you can see that here. It shows you the weight, 128 pounds. The length is 21.1. The length of the motor and the drive is 89. The system efficiency, as we noted before, it's 91.3% efficient. It's continuous duty cycle. It shows you how to drive. The service factor is 1. It's a totally enclosed fan-cooled motor with an IP rating, IP54 for the enclosure rating. Here's the electrical section. It's as expected, it's 460, it's 3-phase, it's 60 hertz. And the key value in this section is a 7.1 amps. It's motor insulation class B. It also shows are the grounding types. There's grounded Y and Delta or HRG. On the mechanical section, this, like all motors, can go clockwise or counterclockwise, depending on how you set them up. It's aluminum frame. It shows the inertia, the bearing types, the grease type. We do include grounding brushes. You can see the grounding brushes I mentioned here. It's a keyed shaft. And these particular motors have 2 mounting types, horizontal or vertical, and the mounting type is C-face or body mount. I mentioned the ambient operating conditions. It's called out here. It's 1,000 meters and 40 C. This section of the data sheet, like every other industry standard motor, has normal connections for analog input, analog output. We do provide 24 volts DC if you want to run that as an input. There's digital inputs, digital outputs. We do have a relay. And as I mentioned, we support Modbus RTU or BACnet MSTP. Both are available. And there's an Ethernet connection for the motor control software. It's called Modbus TCP. Certifications are down here. There's UL, CSA. Here's drawings explicit to the number that you selected. So this is a 20-inch frame, and these are the drawings you can see for a 20-inch frame. And the last page of the data sheet includes a catalog number decoder. This is true for all Infinitum motors. The catalog number includes the family, the frame, the power, the speed, the voltage options, the drive and I/O, the bearings, whether it has wireless support or not, the enclosure rating, and the grounding type. You can see there's grounded Ys and Delta HRG. But down at the bottom are the particular ordering options for your particular motor. You can see there's various flavors of Modbus and MSTP and steel bearings, etc. You've chosen the one in bold. So this selection at the top is the explicit catalog number of your particular motor. You can see it includes Modbus RTU, steel bearings, and a grounded Y, which is represented by this bolded catalog number. And with that, I'm going to pause and see if we have any questions queued up.
Thanks, Cam.
Sure.
A reminder for all of our attendees, if you have any questions, feel free to use the Q&A feature at the top right of your screen, and those questions will go directly to our moderator, Luke, and our experts will answer here live on the floor. All right. Looks like we have our first question from the field. I believe this is for Stephen. How is the right-sized motor physically different from a standard motor?
Okay, it's a very good question. We get this question all the time. Physically, the right size motor and a standard motor are almost the same. Obviously, the main difference, as we explained, is in the nameplate. The right sized motor has a different nameplate label, and the standard motor has a different nameplate label. Externally, that's pretty much the difference. Internally, for the most part, the difference is in the software. We do limit the speed for the right size motor, and so that motor cannot speed up and consume more power. So that is the internal difference. In some rare cases, we do change the internal impeller to optimize the cooling. That's very rare, but internally, that's the extent of the change. So I think that answers that question, but it's a good question. Thank you.
Thanks, Stephen. We've got another great question from our attendees. I don't know if this is Cam or Stephen who'd like to answer.
Okay.
Is it possible to convert a standard motor to a right-sized motor in the field?
I'll take that one. And the quick answer is no. You know, a label is a certified ETL label, and it's set at the factory. So a 1018 should say a 1018, a 591225. We can do it with the tool, but not in the field, right? So it's a factory setting for this.
Perfect. Thanks, Cam. All right, one more question from our attendees. How does D rating work for the motor selection tool? I need a 1800 motor, 45C, and 1500 meter elevation.
Wow, so you want me to do this live? Okay, no problem. Let me fire it up. So what's the motor size?
A 1800.
I think a 515 or 518, yeah.
1800, okay.
At
And-
45 degrees Celsius
Okay.
and 1500 meter elevation.
1500. Okay. So what I've done is, if you can see at the top, I entered 1800, 45C, and 1500 meters, and I'll hit the submit button. And you can see what this means. This is a standard motor. So derating between the two of them has derated the motor by 15% due to the operating conditions. So they're done separately. You know, the temperature is one derate and the altitude is another, but the tool has combined them. And you can see there's a lot of information on the screen. So the changes are in red. The standard rating was in black. So before derating, this is a 7.5 1800 motor. So before derating, the rated power is 7.5. If you do derating, it goes down to 6.4. The speed stays the same, of course, and efficiency changes slightly, actually goes up slightly. And the rated amps go from 9 to 7.6. So everything is reduced. The derating reduces the performance of the motor to adjust those operating conditions. You can also see the torque torque changes as well. So we go from 30 Newton meters down to 25.5 based on this derating. Any questions after this, Jill?
Thanks, Cam. We've got one more question from our attendees. Does the right-sized motor still provide enough power for design days?
I think we would need a little more clarification on design days. I guess it's an HVAC term. So we can take another question and then come back to that.
Okay. Another question from our attendees. Is it possible to upgrade? I'm sorry, that's the one that we just looked at.
Oh, that's right.
Okay. Is it possible to upgrade the insulation class? Currently rated at Class B, would there be a higher risk of failure at an elevated temperature in data centers, either for the PCB or the stator side?
So let me take that answer. I think it's a good question.
It's a real good question.
It's actually not related to the motor selection tool or right sizing. It's a generic question about the technology that we use. So first of all, insulation class. The question is it possible to upgrade the insulation class in the field? And the answer is no, because the insulation class is inherent to the PCB stator and the way the motor is manufactured and produced in the factory. So you cannot change that in the field. Related to that, I think it might be important for our audience to understand the PCB stator that's used in the Infinitum motor. Actually, it's very unfortunate. We are at 150 degrees C, which is 5 degrees lower than a class F. So it's unfortunate the certification agencies puts us in the class B bracket, insulation class B bracket, although the material that we use is fairly close to a class F bracket. So it's a little, it's an esoteric subject to explain it over the webinar, but we have an excellent white paper on our website that explains why we are not class B and we are actually closer to class F. However, due to the way the MG1 standard and the certification agencies do their labeling, we are put in a class B bracket. But we do have a white paper, as I explained, that explains it. But we will also be doing a webinar in the future to kind of explain some of these subtleties about the technology in the product and some other features that we have. Hope that explains the question. Let us know if you have any follow-up questions.
Thanks, Stephen. We've got one more question from our attendees. Does a right-sized motor and a standard motor cost the same?
That's also an excellent question. We get that all the time. Obviously, a right-sized motor has a lot more that goes into it. There's additional software settings, and in some cases, as I said, the internal impeller needs to change to optimize cooling. But in terms of pricing, that's a question for our sales team. I would suggest we refer that question to our account executives who can answer that. And it's a question they can answer based on volume and a lot of other factors.
That was excellent. We have a data sheet question for you, Cam.
Uh-oh. Okay.
What data appears on the D-rated motor's nameplate? Is it a standard or corrected data?
It's a good question. So it's a tricky question, actually, because the nameplate won't show that. The D-rated information is used by the factory personnel. So in this particular example, on the screen here, you can see that this D-rated motor produces 6.4 horsepower. As long as the nameplate is less than that, the nameplate won't show any difference. So it won't show that D-rated information on there. It's actually built into the label. But the tool uses that to create this. So we create the motor based on the D-rated information of the standard motor. The label won't show that.
Perfect. Thank you for answering that. Quick reminder for anyone on the call, if you have any additional questions for our experts, feel free to put them in the Q&A window.
Any other questions?
Any other questions from the field? All right. Well, we appreciate everyone's attendance today. Thank you for dialing in for our Right Sizing Motors webinar. If you have any additional questions after today, feel free to reach out to our team or your representative, or you can always contact us at goinfinitum.com/contact us. And we welcome all of your thoughts and feedback on LinkedIn and follow us on YouTube. And if we did not get to your question today, we will be following up with a Q&A session for all of our attendees.
Sure.
Thanks a lot.
Thanks a lot. Bye-bye.
Bye-bye.